Not a, what kind of a graph is this one? Example 3. It's a velocity graph. Now, the reality is that you see all these motions that are happening, and you notice that these parts right here, the vertical parts, that wasn't what I wanted. These vertical parts that we're talking about right here, notice there's no time that occurs over, does it? No. And that's not really the way real life is. In real life, it would look more like that to switch. All right, kind of a change in speed sort of thing. But this is an introductory physics class. We like to keep things kind of simple. So we're going to say, yeah, they just change speed automatically. Nothing, boom, just magically. Okay, so for this one, the first thing I want you to do is I want you to tell me on your board at which of these places is the object at rest. Write it down on your board. Flip your board over. 2, 1, show me your boards. Okay. So, what is the only speed at which something can be at rest? 0. And if you're on a velocity graph, there's only one place that is 0. That makes...
Me either, I didn't see that either.
Uh-huh. Yeah, there we go. All right. Next question. Which one is moving toward? Three, 2, 1. Show me.
You said towards, right?
Mm-hmm. Okay. So to figure out where we have a mix of A's and C's. To figure out which big surprise, we already know what B's doing. All right. What is it we're looking for? How do you know which way it's going? What part of the graph tells you that? Positive or negative. All right. With which one is moving towards? C. Anything that has a negative velocity is moving toward. Would somebody like to do the demonstration for this one? Would you somebody walk?
I can walk.
Can you walk this one?
No.
Okay.
I don't know how to walk.
Would somebody like to walk this one? Think they can do it?
I can walk it, but this is what I'm going to do.
I want you to walk this graph.
Great, you're going to do.
You remember like the motion thing?
Yes, the motion detector stuff.
Okay.
All right, start this. The door is your origin.
Alright.
Okay.
Am I the motion detector?
No, the door is the motion detector. You are trying to match this graph.
Wait. Just have Daniel be the motion detector.
I'm going to get up and start walking just to help myself.
Yes, just don't get up to mess everybody else around. Like, what are they walking now? All right. So, well, here's the last one. Rank these from greatest to least accelerations. Uh-huh. Remember, what is acceleration? What does it look like?
Definitions. I need to redo them.
Okay. All right, well, acceleration is what we kind of talked about today. We briefly mentioned it on Friday.
We did the paper on it.
Change in time. Okay, so, over the portion of A, did the velocity change? Over B, did the velocity change? C, did the velocity change? All right, so it didn't change here, it didn't change here, it didn't change here, so the acceleration everywhere is 0. Now, the thought that I had while you guys were doing this was that there is one argument that you could make. There's one argument that you could make. That would be B A equals C. Can somebody tell me why this would be an argument?
These are at rest.
It's at rest, but what's happening there that makes it an acceleration? That you could argue acceleration. At some point in time, it has to turn around, right?
And there's a turn around
And
before and after.
if you turn around, that's an acceleration. Speed up, you're accelerating. Slow down, you're accelerating.
Oh, yeah, that was in the
Turn around. So, if you had said something like this and you could back it up, like if I asked you why'd you do that, and you would say, hey, well, yeah, they rested there, but they also had to turn around. So I would take that as a good argument. Okay. All right. Last part of this. If I wanted to ask you, thank you. All right, this is what we're gonna do tomorrow, along with the average velocity one from the last one. We're gonna figure out how far did they travel, what was this guy's displacement, and what was his path traveled. Or rather, yeah, we'll find out how far he went in each segment, the displacement for each segment, and the total path traveled. So that wrong. Displacement for each segment and the total displacement. I'm done talking.